Okay, we got it all cleaned up. This is what it looks like. So the one on the left is that original one. You see an undercut right there. The one on the right's the new one. Alright, so check this out. We made our samples. So we took our pipe and cut it into 8 pieces. So we got basically a weld, and from the center of the weld it comes out 3/4 of an inch. And we cut it. You can see this is the back one is the first one we did. This is the second one. So that first one you can kind of see this one's an undercut. That was the only one that had undercuts. So this is the newer one. However, I gotta admit, I don't know which one of these is gonna perform better. But check this out. So these look okay. These don't look bad either. But watch this, I'm gonna flip it over and check these out. Okay, so we flipped them over, and what you'll notice is those first ones have a weld on the back side. Really good compared to the first ones, to the second ones. So here's the first one. That weld bead went all the way, all the way, all the way. Let's see. Yep, all the way, all the way. Well, the edges kinda, but this one mostly, except at the very edge. This one actually looks like all of this. You can see the line where they butt together, and then it popped in there. And this last one, almost all the way except for the edge. Now let's go back and look at the other row. Yeah, the second ones. Look at these. You can see the line where it didn't melt. Here, a little bit of melting, not much, not much, maybe a little. Okay, that's got a bubble in it where it actually melted. That one's got a little spot, really nothing, and a little bit. But I mean, overall, you gotta admit, that first one definitely has a better puddle on the backside. Here you can see like just kind of a cool view. Yeah, see the welds? So you can see these have a curve on the top and the bottom of the weld. Let's see. Yeah, that's a good example. See that? So there's the side that has the pretty weld, but there's a weld on the backside too. Same thing on this one. That's an undercut, but even the undercut one had a big puddle on the backside. I kind of got a feeling these first ones might be stronger. We're about to find out. And if you go back to the second row, see what these look like. So it'll be interesting to test. I've never done this. Well, I haven't done a test this well before. So what we're going to do, we're going to clamp these in a vise. So say it's clamped like this, and we're going to try to bend the side that you see. So it's clamped over here. I'm going to bend that side down on 4 of them. Then I'm going to flip it this way and bend them down. That way you put the stress on the weld differently. So if I push this down, you're kind of stretching the top of that. If I put this down, now you're stretching the spot where it looks like there's no weld, or it looks like it. So I expect these will crack easier when you bend them that way. So it'd be interesting to see what happens. Well, here we go. Alright, so we begin. So the plan is basically, we clamp this in the vise. We got half this length is in the vise here, and the other half is poking out to the weld. Then the rest is hanging out. And we're just going to take a hammer, kind of tap right here, and fold this 90 degrees and see what happens. Okay, I don't think that was a great test. We're going to get up closer on the weld on the next one. Okay, this is the second sample. We got much closer to the weld. This should put a lot more stress on it. See what happens. Okay, we went more than 90 degrees on that one. I can't really see the camera. There we go. That's cool. That held up that way. Yeah, let's try some more. Alright, this is sample number 3. This is that undercut one. hardly focus this. Oh, looks okay. Okay, this will be sample number 4. Oh, I gotta look carefully. That might be a crack there. Not sure if that is or not. That could just be like a scratch from when I made it. I'll have to go back and check the video to see if that was already there. If it is a crack, you can hardly tell. But overall looks good. Alright, now we're running samples 5 through 8. We'll load these in the other way. Now we stretch the back side of the weld. Tension loading. See what happens. Okay, that one did crack. Well, it cracked up here. There's no weld there. I don't see a crack in the actual weld itself. So, let's look at this side. Okay, it did crack there, but we did bend the piss out of that. Not sure what to think, but we're going to keep testing. Just let the camera roll. This one looks okay. Okay, that one looks good. Go to sample number 7. Got a feeling this one might crack. There's not a lot of weld on the back of this one. Yep. Took a while, but it did crack. You can kind of see it cracked where the weld had not made it all the way through the material, and the crack ran down, and actually the crack stops where the weld is. So, kind of interesting. Here's the welded side. Looks good. So that's kind of what you would think. You don't get full penetration, and then you try to rip the weld open and it tears. So this kind of tells me that the second samples we did are probably going to be worse, not better. Here's sample number 8 from the first weld. This one's actually got a decent weld, so if it cracks, it's probably going to be down here at the bottom. Nope, cracked at the top. And it cracked it in the heat affected zone, not in the weld itself, but in the area immediately next to the weld. I don't know how good that shows up on camera, but there's a crack near my fingernail there. But, I mean, we did bend this 90 degrees pretty hard. Okay, now let's try the next group. Alright, here's sample number 1 from the second weld. Looks fine. Alright, grab the second sample. Here's the second one. Seems fine as well, no cracking. Go to sample 3. Looks good. Like I said, I think all these are going to do fine when you put the weld in tension. This is the last sample that we're going to do that. These are probably all going to crack when we do it the other way, since these didn't have as good a penetration to the other side. But that's why we test, to find out. If it turns out my assumption about this weld is wrong, then it's good that we tested, because then we find out. I'd rather be mistaken and then corrected. I don't see anything. Okay, so all four welds in tension on both welds have passed. Now we're going to go to samples 5 through 8 for weld 2. These will likely not fare as well. First one. Huh, that made it. Wasn't expecting that. But that didn't crack. Let's go to the next one. Oh, that one's cracking big time. Ripped it open. At least in that one spot it did. All that up there held up. Okay, that's only 2 samples. Looks like right there we really didn't. Maybe it just ripped, I don't know. Let's go to the next one. Still got 2 samples to go. We'll do the test, we'll draw conclusions in a minute. Oh yeah, that one's the worst one yet. Look at this. That's horrible. Look at that. There we go. That's a brittle failure. That was bad. So it looks like that weld just split open. If I bend this, I'm sure I can break it. Oh, I thought I could. Okay, I can almost break that. But yeah, that one totally just ripped it open, and that cracked. So this one was brittle. That's the first one we've seen that was brittle like that. Here's our last sample. Okay, this will be number 8. Making damn sure I got all these at 90 degrees, so I'm not cheating. That one cracked too, but predictably it cracked where the weld isn't and stopped where the weld is. So, interesting. Alright, let's review this. Alright, so let's review. So So the first 4 passed on both welds. So we're going to ignore that for now. All of these passed. That was putting the weld in tension. Now here is where things get interesting. Which is where we put the back side of the weld under a load. So let's see. This one cracked. This one did not crack. That cracked. So we'll put that one in the back since it didn't crack. This one, well, it cracked too, but not as badly. So 3 of those cracked. So this one, that one didn't crack. I'll put it in the back. That definitely cracked. Ripped wide open and cracked. So really the score is the same. 3 of these cracked, 1 of them didn't. 3 of these cracked, 1 of them didn't. And let's judge the severity of the crack. Here, it only cracked until it hit a weld and it stopped. This one, actually the same thing. And this one, let's see, we said, okay, this one cracked in the heat affected zone. So 2 of these cracked where we didn't have material. This actually cracked in the heat affected zone. And then of these 3 that cracked, that cracked where we didn't have material. This one didn't have material and totally just brittle failured. And this one cracked where we didn't have weld. So, my takeaway is that these welds are decent as far as strength. All of these passed in tension. And the backside is really just, to me, this is telling me that for the strongest possible case, I need to make sure I'm getting full penetration and actually getting a weld on the backside of the material. So what I was doing when I welded this, I was kind of going hot and fast. So I'm going to have to think about this. I'm going to do a little more research, but it looks like I might need to do a 2-stage. Either I need to adjust my 1-stage welding or go to like doing a root pass and a filler, or a root and a cap as they say. Because this isn't perfect results and I would like to see this improve. So I believe I'm going to end up doing some research and we're going to do all this again, see if we can improve upon our results. This isn't terrible because I guess a lot of welds would get loaded in this direction and they all passed. But yeah, if you tried to bend a tube against the weld, then these don't perform as well. So interesting test. We'll see what conclusions we draw. Oh yeah, so a final note about our testing here. So we are kind of making this more difficult on ourselves than we have to, and that's because these samples are curved, because I cut this out of tubing, so you can see there's a slight curve. And what that does is when you're bending it is you're really trying to stretch the edges. So basically we're trying to bend this to see if it cracks, but we're putting a huge amount of stress right on the edges, which are saw cut, not polished. You know, it's a very big stressorizer. And I think every crack, I bet you probably every single crack started from an edge, because that edge is just under so much tension. Let's see, that one started from an edge. Yeah, that's every single case that started from the edge. So that's really not surprising because we're just putting a tremendous amount of stress from that being a curved surface. So that does make it harder to pass, but it's also easier to do testing this way. But thought I'd point that out.